just started the recording. Zoom's supposed to have something that's supposed to record these sessions, but it didn't work. So I'm just getting used to Zoom, so I'm doing it the way I used to do it when I recorded it myself. Alright, now let me go here and share my screen. Alright, and let me take you to practice quiz. Problem number 1. Go ahead and solve this. And if you could have your cameras on during the practice quiz, and then you can turn them off, then that'll be great. And then I can also get a few visual clues. I can kind of tell when people are done a little quicker by looking at people's faces. Okay, 30 seconds more on number 1. Alright, so there's the solution method is this. We break this up into 2 equations. Either the absolute value isn't doing anything, in that case x was 5, or the absolute value is stripping off the negative sign, in which case x had been negative 5. So in general, an absolute value equation will give you 2 solutions. We have these 2. Alright, so let's go to part B, and absolute value of y is equal to negative 4. Go ahead and solve that one. Alright, 30 seconds more. Alright, so I'm going to do this the same way as I did the other one. I'm going to use the solution method. Y equals exactly that number, or y is equal to the negative of that number. And that would lead me to y equals negative 4, or y equals 4. And my first instinct is to just say, alright, these are the 2 solutions. But it turns out this is all nonsense. The real solution is that there is no solution. The method that you would use leads you to the wrong answer. Why is it that there's no solution? Well, when you take the absolute value of something, what do you always get? A positive result. This is nonsense. The absolute value of a variable gives you a negative number is impossible. So the solution method is subjugated to some reasoning. We have to just kind of look at it first to see, does the problem make sense? And if it doesn't make sense, that overrides everything. The steps in the technique are only a subset after that, whether the problem makes sense or not. So we have to just say no solution. All right, give me some feedback on, so let's go to the chat on A and B. Go ahead and type it in, but don't hit enter quite yet. And go ahead and hit enter. And go to part C now. Alright, so some visual cues that I'm going to be using is if I see you staring down at a paper and pencil moving, I'll assume you're still working on it and need a little more time. And if I see you with a pencil down and you're just kind of looking at the screen or looking around, then I'll assume you're done. I won't always wait till everybody's done. When kind of the majority looks like they're done, that's when I'll start. Alright, let me start on this. So we'll subtract 1. So the first step here is to isolate the absolute value. And then we divide by 2, and then that gets this thing, this absolute value expression, isolated. And once you have it isolated, then at this step, it's just as, now how I often think of it as, what if this was replaced by a single letter, like y? Then I'd say y equals 4, y equals negative 4. And so I treat it the same way. And then solve each of these equations. Add 1 to both sides. Divide by 3. Add 1. Divide by 3. And I get 2 solutions. Now, if you have 2 individual solutions, you can just put a comma between them, or you can put the word or you can put the word and. None of that makes any difference. The time when and or makes a huge difference is when you have intervals. And then when you separate the intervals from here to here, from 3 to 5 and so on, separating those with the word and or is critically important. But when it's just two individual solutions, I usually kind of avoid both of those words just because I don't want to get the confusion started with sometimes students. Then it's not important. These are both solutions. If you check them, they both work. Let's just check the easier one. Put -1 in here. If I put -1 back in here, I'm going to get -3 minus 1, which is -4. The absolute value of that is 4. 4 times 2 is 8. 8 plus 1. 8 plus 1 is 9. It does check. This one checks. And if you plug in the other one, it'll also check. Okay. And, alright. Let's go to part D. Solve that. Okay, 20 seconds more. Alright, so from facial expressions, it looked to me like some people were struggling with this one. So, I'm going to go over some basics. Absolute value of x means the distance from 0 on the number line. So, we want all the numbers x whose distance from 0 on the number line is smaller than 2. So visually, it'll look like this. If we need the distance from 0 to be smaller than 2, it's everything between here and here. And so the solution then could be written multiple ways. Could be written x between -2 and 2, could be written from -2 to 2 like this. That's an interval notation, that's as an inequality, and there's written as a number line. Alright, do part E. Solving that one. Okay, 20 seconds more. Alright, so here we need the distance from 0 on the number line to be larger than or equal to 3. So that's going to be the case if we're way over here, we're way over here. And so the solution is going to be x is less than negative 3, less than or equal to negative 3, and then the key word has to be or x greater than or equal to 3. In interval notation, it's from negative infinity to negative 3, union 3 to infinity. And this, to contrast with this is the same as x is smaller than negative 2 and x is less than 2. This is an and situation, and situations can be pulled together into one double inequality, or situations cannot. You get two separate ones like this. Alright, give me a little feedback on C, D, and E, please. And type it in, but don't hit enter quite yet. Go ahead and hit enter. Okay, question. When do you use the brackets instead of the parentheses? And, okay, so, okay. When there's no equal sign underneath, then it's an open circle. Don't include the endpoint. 2 is not part of that interval. If this had been an equal sign, then you would fill in these open circles. And then these would change to brackets if there was an equal sign. So, less than. So open circle is associated with the parentheses, closed circle with the brackets. Any questions? Anybody confused on something and want some extra clarification? Just pop in with a question. Okay. Alright. Now let's go to F. Solve that inequality. Okay, 30 seconds more. Okay, so this being a less than inequality, I treat it as if this was just the same way if this had been replaced by a single letter y. If it was y less than or equal to 7, then what would I do? I would do y trapped between -7 and 7. So it's not a y though, it's this, but I do that same expression. I treat it the same way. -7 and 7. And then I'm going to divide by 2, do all three sides. Now if this was dividing by -2, I'd have to switch both inequalities. And then get this answer, and that's the same as the interval from -2 to 5 in brackets. Alright, and now let me have you do the next one. While you're working, let me explain. I have vision difficulties. When I read too much or look too much at screens, I get very severe headaches. It's why I have a grader that assists me with the grading that's beyond my capacities. And so you'll see me, like during practice quizzes and other times when you're working, usually you'll see me looking off in the distance to give my eyes a rest. Okay, 20 seconds more. Alright, my first instinct would be to just follow the procedure. If that was a y, I would do 2x minus 3 between this and this. This on one side, the negative of that on the other side. But that is all nonsense. The real solution is no solution. Because I just look at it and say, when you take the absolute value of something, you always get something positive. How can a positive number be less than or equal to -7? Which means to the left of -7 on the number line. Impossible. So this is no solution. Alright, give me a little feedback on these last couple, F and G, in the chat. I'll tell you when to hit enter in a moment. Okay, go ahead and hit enter. Alright, well, this is the last practice quiz problem. Go ahead and do H. And this OneNote thing, it'll whenever I create more space or anything, it'll renumber and re-letter all my things. So I've learned little tricks with double letters and call it part 1 and so on. Okay, 30 seconds more. Alright, so once again, if this was like the letter Y, get stuck now. If this was the letter Y, then I would say Y is greater than 7 to the right of 7 or to the left of negative 7. So that's what I'm going to do here. 2x minus 3 is to the right of 7, or 2x minus 3 is to the left of negative 7. Because on the y part, if it was y, it would clearly be way over here, or way over here. And we're doing the same principle here. Now I'm going to add 3, add 3, and then I'm going to have to put the word or in between these, and then this part over here is negative infinity to negative 2 union 5 to infinity. Alright, and this time, feedback. Give me something on your comfort level with these last the last 3 problems, these absolute value inequalities. Like, I feel like I really got this down, I can handle all these kind of problems, or I really need more practice on these. Give me some kind of indication on your comfort level in the chat. And go ahead and hit enter. Okay. And questions on the homework procedures, any issues that came up. Okay, nobody has any questions? Then, all right, let's go to the next section, domain and range. And when we get a little further into this section, like yesterday, I'm going to be putting you into groups, and you'll be randomized this whole week. But your group today, your assignment will be to check problem number 42 in 3.2. So you'll figure out when you're going to get together and make sure that you all understand that particular problem. And before jumping into 3.2, I want to go back to here. How do I get this? I want to get, alright, I'll go to here, and let me go to Canvas, to the site, alright. A little bit more about how this course is structured and how things are going to work. And let me go into the modules. In the Zoom, oh, by the way, let me show you. In Zoom, they're supposed to be here under Cloud Recordings. These didn't really record our class, so those are useless. So in the modules, I'm going to insert a new module, probably put it right at the top, which has the recordings of each class. So today's class is being recorded, and when you are studying, if you decide, oh my gosh, this one part that you had to rush through kind of at the end, I really didn't understand, and I want to see that portion of the lecture again, you can view the recording. It'll be up here. And scanning and submitting homework. I want to kind of go over this thing here. I get a much better image if you use a scanning app. And a specific scanning app is thrown out there, but there's lots of free ones out there. And also you can be put it into any scanning app, as far as I'm aware, has a batch mode where you can scan multiple pages and it'll put it into one PDF document. And so then you only have one upload. It's way quicker. I get a lot of people who give me, 6 different uploads for 6 different pages, and they're wasting a bunch of their time. And it's easier for me and my grader if it's just in one document as well. Also, if you want to get the Canvas app on your phone, that might make things really simple for you, because then there's no longer that you have to transfer an image. Take a picture of your homework and then transfer it to your computer and then get it into Canvas. If you've got the Canvas app on your phone, you take the picture and then whoop, you just stick it right into Canvas. The assignment list right here for the rest of the semester, showing which problems on each section. Notice in each problem set, like 2.6 for today, there's a review portion. So every problem set has the first part of it is stuff that is part of the homework, but they're review problems At the beginning of the semester, it's kind of like skills that we assume that you have, that we want you to refresh. And then as you go on later in the semester, the review problems will be problems from previous sections that we've done in this class. Okay. So, I showed you our teaching schedule last time. And then, so for each of these sections, you'll notice there's a spot check. So today we're going to cover 3.2. You can click on the spot check, and there's an upload there to get that done before we start class tomorrow. And then there's the practice, the actual assignment, to upload the full 3.2. This one only needs to be 75% complete. This should have everything complete. What you will find most of the time is that you get stuff done for the spot check, and then when we have the practice quiz in class and people ask questions on the really tough ones, you get more insights, and it helps you go back and finish every last problem and correct the errors that you've identified, and then that's what you upload into the full version, the practice one. And if by chance though, when you did the original spot check, if you had completed it 100% of the way, and you didn't have anything that you want to correct, then you don't need to upload anything into the practice 3.2, that part. If myself or my grader, when we see this is empty, no upload has happened in this one, we will assume that you want me to grade the thing that's in the spot check. Okay. But do not upload part of your assignment in the spot check and then the other part that you're missing into the practice section, because that's too difficult for me and my grader to go back and forth between two files to try to find the problems. So most of you, most of the time, most of my students wind up doing two separate uploads. One for this, and then a later one for when they have the whole section done. And that'll probably happen most of the time for you. When we get to exams, as we get close to exams, you're going to find there's a practice exam. Then there's going to be, I'm going to post the answers to the practice exams. And then you're going to have to correct your own practice exam and post with errors corrected. And that'll get you ready for the exam. And there'll be a discussion related to the exam that's a point, that discussion you have to participate in. You'll miss out points if you don't. What else? I want to go over simple syllabus. We looked at a lot of this stuff. The grading criteria is pretty standard here at the community college. The late work, really big penalty if you get behind and stay behind. If you've got something that comes up and you just need more flexibility, or if you tell me right off the bat at the beginning of this semester, I've had students that tell me, hey, I work, I have kids, I'm going to need a different kind of a thing, and the spot checks aren't going to work for me, and I'm going to have to do all my homework on the weekend. That's no problem. As long as you tell me that at the beginning of the semester, I'll flex. I'll give a lot of flexibility. I'll do what works best for you. That's my objective. Get something that produces the best results for you. But where I'm not flexible is, if later in the semester you come and because you're missing all these points for spot checks, and you say, oh, well, let me not do spot checks, and I'll say no. That's a requirement of the course, and just because you're not able to, accomplish that, doesn't mean we get to change the grading system for that. So not flexible later, but if you approach me at the beginning here, tell me what your needs are, we can make it work. Okay. And the schedule, everything's in here. Any questions on how this course works? All right. Let's go to domain and range, 3.2. All right. The domain is the set of all possible inputs for a function or a relation, and the range is a set of all possible outputs for a function or relation. Now, what we're skipping here is what's a function and what's a relation. If you need a quick reminder of that, functions, they pass the vertical line test. So, you ever seen a stock market curve that looks like this? No. A stock market curve that looked like this is nonsense. Why is this nonsense? Because at a given day, day 3, there isn't just one closing price, there's 3 closing prices. You know, you'd look back here and say, oh yeah, what's the closing price of the stock on this day 3? Well, there's 3 different choices. So this is nonsense. To be a function, each input has to have exactly one output. If it has more than one output, so a function also has this, each input has exactly one output. And if it has more than one output, it won't pass the vertical line test. The vertical line will hit the graph in more than one point. Alright, so the domain is the set of all possible inputs. The range is a set of all possible outputs. And then you're asked to state the domain and the range for this situation, where the input is the number of miles driven, the output is the gallons of gas used. And so what I'm going to do is I'm going to give you about a minute to think about this individually, and then I'm going to put you in groups, and I'm going to have you discuss what your answers are so that you come to something that you agree with in your group. So I'm going to give you just a little bit of individual processing time first. And yes, you can turn your cameras off now. Send you into breakout rooms. So before I send you to breakout room, instructions are introduce yourselves again, and then go around one more time and state everybody else's name so that everybody knows each other's name, and then determine alphabetical order by first name, not the first person but the second person. So if you have Bob and Charlie, Charlie would be the spokesman for the day. So in alphabetical order, the second person in alphabetical order by first name is the group spokesman for today. And, alright, so let's go to 3 groups, and there you go. Okay, you should all be back now. And I thought I was going to give you a full minute to close out, but it closed you out in 10 seconds. And let me ask group 1, any ideas you have for the domain and the range?
I don't think we got a chance to decide who was the spokesperson.
Ah, okay. I did it probably too quick on this one. So Madeline, did any ideas come up for?
For which one is the domain and range?
Yeah.
Wouldn't the domain be the miles driven and the range is the gallons of gas used?
Okay. Now that is exactly what I would do if I was in your situation. It doesn't turn out to be correct. And let me see if I can get to the top. Oh, I can move this whole bar. All right. All right. So let me go to draw. All right. That seems intuitive. Just restate, because this is the set of all possible inputs. The set of all possible inputs has to be, now, but it represents the miles driven, but the set of all possible inputs, and actually the answer that you're stating is quite reasonable for this description. This description isn't quite precise enough to really know what's meant. But you have to state what numbers are allowed and what numbers are not allowed to give the set of all possible inputs. So for instance, is -3 allowed?
No.
No. So what kind of numbers are allowed? And so this has to do with the inputs, which we typically call x. We might say x, some condition on x. So the condition I'm going to put on x would be, now 2 possibilities come into my head. X greater than 0 or x greater than or equal to 0. Madeline, while you're there, I'm going to ask you, which of these two makes more sense to you?
I think the greater than or equal to 0.
That is correct. you can have days where you drive your car not at all. It doesn't drive at all. So x is 0. And then the range would be a restriction on y. So we might say, now number of gallons of gas used, we'd say the same kind of thing. Can I have y be negative 5? No. So y also is going to be greater than or equal to 0. All right. Now, this is one way the domain and range can be stated. Another way it can be stated is like this. Domain, and you give it an interval notation. 0 to infinity. Range, and you give it an interval notation. 0 to infinity. And this notation tells you what letter we're using. Well, kind of our default typically is x and y. They don't have to be. Right? But this notation, kind of, you don't see the letter at all. All right, let's go to the next one. And this one is a little trickier than it seems. And so think carefully about this one. You're stating the domain and the range, where the x is the number of lollipops sold and the y is the revenue. And let me send you back into your breakout groups and finish making sure that you have a spokesman for the day in your group, and that you talk about this. And I'll give you about a minute or two, but that's about it. Breakout rooms, open all rooms. All right. So let me ask group 3.
Uh,
What do you have?
Hi. So for the number of lollipops sold, that's going to be the input, and for the revenue, that's going to be the range. So,
All right.
the domain is going to be number of lollipops sold.
Domain x, the domain has to do with X, which is the number of lollipops sold. And the range does have to do with the Y, which has to do with the revenue. Alright, so that's a good start. But we need to get specific. What kind of numbers are allowed? Could X be like negative 2, Brandon?
No, right?
Maybe.
Unless we're like taking, I guess, like the consideration of the, I guess, supplies, like how much money we use to buy supplies. I don't think it could really go negative, but that's like even on the just revenue. I think just the domain, I don't think it could ever go negative because you don't ever like unsell a lollipop, right?
Alright. So, alright, let me clarify what revenue means as well. The revenue is just the money that you take in from sales. It is not the profit. It doesn't take into account how much you paid to get the lollipops. It's just how much came in from the sales of the lollipops. And that other part is what you call the cost. And then revenue minus cost is what you call profit. But this is just how much money comes in from the sales. And you're correct, we cannot sell a negative number of lollipops. That doesn't make any sense. So would this be the case? X greater than or equal to 0. You can only sell a positive number of lollipops. And then could you make a negative number of revenue dollars? Remember, revenue is just money coming in. It doesn't have anything to do with the cost. This seems like it should be y. Y greater than or equal to 0. Let's go into the chat real quick. And everybody tell me in chat if you agree that this is correct or disagree with this. And type your answer, but don't hit enter yet. I'll tell you when to hit enter. So go ahead and hit enter. All right. So we've got one disagree from Israel. Israel, can you explain? Why did you put down disagree?
I put disagree because they're $3 each, and so if you sell only one lollipop, you can't make only $1. So it starts automatically at 3.
You're right.
It's
On
$3
track.
each.
That is exactly it. This at first appears to be correct, but it is not. You can't sell half a lollipop, a third of a lollipop. If somebody says, break that lollipop into 3 pieces and then, I'll give you $1 for one of those pieces, you probably aren't going to do that because nobody's going to buy your other broken lollipop for $2. You're going to sell them as whole lollipops. X, in this case, is just these positive whole numbers. That's the number of lollipops sold. And Y, Israel, what should I put for the Y's? What numbers here?
Multiples of 3.
Very good. You won't get $4 in revenue. You can get 3 or 6 or 9, but that's it. Okay. So it depends on your situation and the context of what makes sense. Over here, yes, we can drive half a mile and use 3.2 gallons of gas. But here, we can't do fractions. All right. So now these two problems are domain and range problems within context. Most textbooks, this one included, rarely gives math problems in full context. It abstracts the idea and it looks more like this one. So f of x is the square root of x. And we're asked to find the domain and the range. When you have this, when there's no context, for domain and range, the only thing you're going to look for is, are there illegal values, inputs or outputs? Are there illegal inputs? And are there outputs? That will never show up. So for the illegal inputs, it turns out that you cannot take the square root of negative numbers. If you tried to take like the square root of negative 9, it is not 3, because 3 times 3 is positive 9. If you take negative 3 times negative 3, you get positive 9. The only way you can get negative 9 is if you take positive 3 times negative 3, but that's not a number times itself. This is illegal. Now, when you get to imaginary numbers, you imagine they exist. We're not to those at this point. So we're going to just say this doesn't exist. So the domain is just from 0, we'll write it in interval notation this time, from 0 to infinity. Now infinity always has a parenthesis, and on this side you have a choice. Do you put a parenthesis or a bracket? If you put a bracket, that means that you're saying you can take the square root of 0. And you can. The square root of 0 is 0, because 0 times 0 is 0. So that the domain, we addressed this question, and we avoided the illegal inputs. For the range, are there inputs that will never show up? Well, whenever you take the square root, what is the square root of 9? Is that equal to 3 or plus or minus 3? It turns out it's equal to just 3. The square root symbol, the full name for this is principal or positive square root. We always shortcut that name when we talk about it, and we just say, oh, it's the square root. But its real full name is principal or positive square root. Because there are two square roots of 9, 3 and negative 3. But there's only one principal square root, which is positive 3. And why did math decide that we wanted this to mean just the positive square root? Well, we like things that are functions. When we punch square root of 9 on a calculator, we don't want two answers. We want one answer. We prefer things that just give us, for one input, we just get one output. So square root was turned into a function that way. So this has the same restrictions, 0 to infinity. You'll never get negative numbers as a result of square root. All right. We're going to look at more of these abstract ones, kind of like the one coming up there. But let's take a break now. Let's start again. At 9, we're going to add 15 minutes. 52. At 9:52 a.m. And does anybody need to speak with me individually before I
I
take
have
my...
to.
Yes.
Sorry.
I have 2 questions on the homework.
Great. Are there questions that maybe we should address for the whole class?
I guess they could be.
What are the questions?
I had a question on 15 and 21. I just was wondering if 21 would be no solution because it was.
Now, is this 2.6?
This is 2.7.
2.7. Let me flip over to there. 15 and
21.
21? Yes. You know what? Those are great questions for the entire class.
Okay.
So let's, we'll start with those questions when we come back.
Awesome. Thank you.
All right, thank you. All right, so let's get started again. And Sarah had asked about these two problems, 15 and 21. And these are great problems to look at. 21 is the easier one. The absolute value of something. So replace this. How I make sense of something nasty is I replace everything in there with, because once you evaluate it, suppose x is 10. 10 minus 7 is 3. You still get a number. And that number, let's just call it y instead. The absolute value of y is less than negative 4 is impossible, because the absolute value always gives you a positive number. So whether this was a y or any other expression, you get no solution. This one is the opposite case. Replace x plus 9 with y, and this is saying the absolute value of something is always larger than or equal to negative 6. Well, you know you're going to get a positive number, and every positive number is larger than or equal to negative 6. The solution in this case is all real numbers. Every single number is going to produce a positive number, and every positive number is greater than or equal to 6. Now there's a shortcut notation. Sometimes we write the solution this way, with a script R for all, shortcut for all real numbers. Sarah, does that answer your question?
Yes, sir. Thank you so much.
You're welcome. And I'm sure you're not the only one that wanted extra clarification on that. Those are good ones to look at. All right. Was there any other questions anybody had before moving on? Okay. Let's go on then. So we have this one. To figure out the domain and the range on this. And I'm going to have you do it two ways. Method number one is by trial and error. Just start plugging in some numbers and then see if you can figure out what you think the allowable numbers. You're going to get some restriction on W over here. And then you're going to get some statement about M over here for the range. And then try to figure out what what are the numbers that work from trial and error, and then we'll try a new method after that. So let me give everybody a minute with this. Okay, let me have you stop, and I'm going to state this. Trial and error, if I try big numbers like 10, 9 minus 20, that's negative, it doesn't work. If I try even bigger numbers like 100, it doesn't work. 9 minus 200, I'm going to get negative. And only when I finally get down to 4. See, if I try 5, that doesn't work. 9 minus 10, I mean, I get square root of a negative number, can't have that. But when I get down to 4, it works. Aha. And 3 works. And take it all the way down even to negative numbers. Negative 5. That's going to give me positive 10. plus 9 is 19. That works. All right, so I'm going to say W is less than, look at this, less than or equal to 4. And does everybody agree with this? If you disagree, speak up. Just go ahead and use your mic. Let me know if you disagree. Everybody agrees that 4 is it. All right. Let me give you a hint here. Yes.
Yep.
Jason, what do you think?
I think you could do 4.5 because 9 minus 9 is 0. You can take the square root of 0, which is 0.
Ah, very good. This is the real answer. Not 4, but 4.5 or 4.5. That's right. 4.1 will work, 4.4 will work, and so on. Okay. It's easy to get caught with something else, but we see this. Trial and error might lead us a little bit wrong, but if we study it close enough, we can get to this. All right, now, M. What must be true about M? Well, in the end, you're going to take the square root of a number. You might be taking the square root of 0, you might be taking the square root of 1, but you're never going to be taking the square root of negative numbers. Those are not allowed. So this is going to be M greater than or equal to 0. Alright, so there's my domain and my range. So this is method number 1, trial and error. Method 2, create an inequality. Create and solve an inequality. And this will get us to exactly the same number. So, for instance, suppose this had been M of W is equal to the square root of W. We would have quickly said, oh, I know this. W must be greater than or equal to 0. So, boil this, whatever's in here, replace it with a single letter for an instant, and then say, well, what must be true about that single letter? That single letter must be greater than or equal to 0. Well, we can do that for that whole expression. 9 minus 2W must be greater than or equal to 0. And then I'm going to solve this. Keeps popping up. And I'm going to subtract 9, divide by -2. So let me get some more space here. Now, we had seen that when you divide or multiply both sides of an inequality by a negative number, you must reverse this sign. So then we're going to get here, W is less than or equal to 4.5. Exactly the same answer that we had come up with by trial and error over here. So when the problems get really tricky, you might be better off sometimes going with creating and solving an inequality. Or you could do it both ways and kind of check your work. Okay. And all right, any questions? Let's go to the next one. Here's the problem. State the domain and the range. I'll give you a minute. Okay, let me have you stop. And again, these problems are all out of context. When we started this stuff, we had a couple problems in context. When you have a context, you kind of get to say, well, what's reasonable? Fractions are unreasonable here, but they are reasonable here. Negative numbers are unreasonable in both cases. But when you get problems in the abstract with no context, you're not allowed to say fractions are better than non-fractions, or negative numbers are not as good as positive numbers. No, you're not allowed to do any of that. The only thing you're allowed to look for is illegal values, and make sure you avoid them. And let's look at when you have a fraction, 0 in the denominator. Is that okay? Well, let me just remind you of something. 8 divided by 2 is 4. And how do I know that that's correct? Because this times this equals this. And so 0 divided by 3, let's just call it 0. And then let's check it. Does 0 times 3 give you 0? Yes, it does. 3 zeros add 0 plus 0 plus 0 is the same as 0. Alright, so let's go with 5 divided by 0. Let's call that answer 0. And then let's check it. 0 times 0, does that equal 5? No. This is not true. It turns out division, when you're a child, you might have been taught division as 8 divided by 2 is, there's 8 people, and you want to divide them into 2 groups. How many people in each group? Well, there's 4 people in each group. All right. This kind of way of thinking of division is not helpful when you get to fractions or decimals, top and bottom, or 0, top and bottom. A more generalized way to think of division is, how many times bigger is this top number than the bottom number? So I need how many 2's to add to itself to get to 8? I need to add 2 to itself 4 times to get to 8. That's why 8 is 4 times bigger than 2. It gives you this. Okay. Now, if we use that way of thinking, how many times bigger is 5 than 0? Or how many times do you have to add 0 to itself before you get to 5? Well, you add 0 to itself an infinite number of times and you're still stuck at 0. It is totally impossible. That's why this one is illegal. 0 in the top of a fraction is fine. It's 0 in the bottom of the fraction. Can't have zeros. In the bottom of a fraction. So the domain is, the easiest way to set the domain on this one is, say, x cannot equal 2. Because if x is 2, you get 3 times 0 times 4. And anything times 0 is 0, so it'll just 0 out this whole denominator. And the other one is x cannot equal -1. And when x is -1, you'd get 3 times -3 times 0, but anything times 0 is 0. And then the range, there's no restriction on the range. Well, actually, we usually don't ask questions about the range in situations like this. We just really are interested in what are the illegal inputs that we have to avoid, and we state it like this. Now, we could also state the domain as what it is instead of what it isn't. And that we'd use like interval notation. From -infinity to -1, union 1 to 2. We have to dance around these numbers. Union 2 to infinity. That's the equivalent of that statement in interval notation. All right, let's move on to the next one. All right, and with this next one, there's a graph, and then you have to state what is the domain and what is the range. And on this one, I'm going to put you into your groups again, but I'm going to give you a little time to process this first. So figure out what the domain and the range is on your own. Okay, and let me put you into groups now, and make sure that everybody in the group totally understands what the answers are. That's the objective each time you get put into a group. Okay, so let me ask group 2, what did you come up with for the domain on this one?
We said that the domain runs from 4 to 8, including 4, but not including 8, and the range.
So how do I show that I include 4, but I don't include 8?
That would be the closed circle,
Okay,
and the open circle indicates it's not equal to.
so we'd close the circle over here, and we'd open the circle over here. And then how does that translate when I come over to here in interval notation? What do I do over here?
You'll use a bracket for the 4 and a parentheses for the 8.
Very good. Okay, and then the range?
The range runs from 8 to 2. Those are the possible y values, including 8, but not including 2.
Okay.
So bracket 8, comma 2.
Bracket 8, comma 2, parentheses?
Correct.
Okay, you're really close.
Ooh, we didn't get it?
All right, you're totally right on the domain. On the range, you have to put them in order from smallest to largest. You have to
Okay.
go from left to right. And I'm very glad you made that mistake, though, because this is a very common one. If you go 2 to 8 like this. And in fact, when people do this, like if I said x is less than or equal to 2, and if I draw a picture of that, it looks like this. 2 is right here, and less than or equal to 2, we fill that in, and we do it like this. And then when you write it in interval notation, a really common student mistake is to put 2 and then go backwards to the left, negative infinity. But that's wrong.
Right.
Because we have to go from left to right, we have to go negative infinity to 2, like this. And same way over here. Now, in case you're a little lost, where in the world are these coming from with regard to this? Let me just run through a couple things. If x is 10, y is what? Well, how do you answer that question? You go over to 10, and then you go straight up or straight down, and there's no answer. This is impossible. You can't answer that if this is what's here. So the only questions you're allowed to ask is if x is, and x has got to be a number between 4 and 8. But x could be 4, but x can't be 8. If x is 8, well, no, you don't get an output of 2. If x is really close to 8, like 7.9, you're going to get really close to 2, a little bit bigger than 2, but when x is 8 itself, y can't be determined. So that's why this is the domain, and the range are all the possible outputs, and you got to go from smallest to largest. So when you have a graph, and you're asked for the domain, one way to think of it is you're being asked from how far left to how far right on the x-axis can you go. You go from 4 to 8 on the x-axis, and then for the range, it's from how low to how high can you go. You can go from 2 up to 8, and that's it. All right, let's go. Let me have you do this one on your own. I'll give you a quick minute. All right, let me do it now. The domain is what are the possible inputs? Well, you can go infinitely far to the left. So it's from negative infinity all the way up to 1, including 1. And the range, what's the smallest possible height? Height of 0. And since it's a filled-in circle, I include that. If it was an open circle there, then I would not include it. I put parentheses. And then it can go, this is going to go infinitely high as well. Like this. Any questions? All right, so we're done with domain and range. Now let's go to this next part, piecewise functions. And we have a situation to start with. I'm going to put you into groups, but I'm going to have you work on this individually for a little bit first before you go into your group. So assume there's 20 inches of snow on the ground at 8 p.m. We've had a lot of snow. And then it begins to snow 2 inches per hour for the next 5 hours. And then it stops. Sunrise is at 7 a.m. and there's no snow melt until after the sun comes up. So, when the time is 8 p.m., X, remember that X, it says begins to snow, okay. X is going to be 0. So X must mean the number of hours that have transpired after 8 p.m. Hours, just after 8 p.m. is what this is really meaning. So 0 hours after 8 p.m. And then I want you to fill in this entire table. So of course at your home you're going to have to kind of make a quick sketch of this table and then fill it in. And we give you a minute for that. And then you're going to be graphing it. Make a quick XY grid on your paper and graph these results. And I'll give you a minute to work individually here. Okay, I'm going to send you into your breakout rooms. And when you get into your breakout rooms, if you really got lost in the instructions and you're really not sure what you're supposed to be doing here, there's going to be a natural tendency to want to fake it. Get in your breakout room and, there's 4 people and 2 of them are talking a lot, and you're just going to want to kind of like be quiet, don't let anybody know that you got lost and had no idea what the whole problem was about. What I want you to do is really change your natural tendency there. The best possible use of the breakout room time is to get everybody oriented. And if you come into it and you just are lost, that's the best possible use, to say, I am lost and I don't understand how to start, and then your group members will help you get going. There's nothing better that could be accomplished in those breakout rooms than getting that kind of orientation, so that then you're set and then you can go on to the next stuff. And also, if you're in the breakout room and you're noticing that somebody's tending to be really quiet, check in with them after a little bit and say, and instead of just starting it out every time with saying, here's what I got, and just say, hey Juan, what do you have on, did you understand the basics, and so on. All right, so let me send you into the breakout rooms. Okay, let me ask group 1. What do you got here?
For the graph, right?
Yes.
So for so for 8 p.m., the snow started with 20 inches. So it should be 20 inches of snow. And then 9 p.m., 1 hour has passed. And then there's 20, and then for 10, 2 hours passed, and so on. And it goes up by 1 each time.
Okay.
And then for inches of snow, there was 2 inches per hour for the next 5 hours. So for 9 p.m., it's 22 inches of snow. And then for 10 p.m., it's 24. And then 11, it's 26. And then 12, it's 28. And 1 is 30. And then it stops. So because it stopped, until 7 a.m., none of the snow melts. So it stays the same for 6 a.m. or 2 a.m. and 3 a.m. and 4 a.m. and 5 a.m. so on.
Okay, thank you very much. All right, so then we go and graph this. And so I'm going to transfer these over. At 0, it's 20. Now notice these are by 1s. And these, to get up to 30, had to have been by 3s. Okay. And so 0, it's 20, would be over here. 1, it's 22, and so on. And I'm going to zoom in on this so that 1, it's 22, 2, and then it keeps going up by 2 inches, 23, 3, it goes up by another 2 inches to 25, and we're getting, if we connect these, it's going to look like this. Now, is it reasonable and realistic for this situation? And Israel, since you're kind of up on stage right now, I'm going to ask this to you. Should I just be putting dots in here and not connecting these dots? Or is it legitimate to connect all these with a real line here? What do you think?
I think it makes sense to connect them because 2 inches don't just fall out of nowhere. That happens like over time.
Very good. And fractions are going to be fine. In 1¼ hours, there's going to be, a little bit more snow and so on. All right? The other thing is, way at this end, we need to we start with an open circle because the graph ends right there. Okay? And then, do I fill in the open circle or do I leave it as an open circle over here? And Israel, what would you tend to say? Fill it in or leave it as an open circle?
I don't know, fill it in.
Yes, you are correct. The reason why we fill it in is because at time 0, it does have a definite 20 inches of snow. All right, now, one part of it that I have wrong here that I need to fix is over here. It doesn't go higher than 30. It gets up to 30, and that happens at hour 5. So 3, 4, 5, straight up from here, it hits 30. And then it gets horizontal after that point. Alright, so here's my graph doing this, goes up to here, and then it slides along horizontally. It's as if there are two parts of the graph. And this is what we call a piecewise function. There are pieces. And there's different rules that take place in certain portions, and then everything changes, and then you go over here. This happens all the time in the business world. They'll have, if you buy paper from a company that provides you paper, if you're a normal customer, you'll get paper at a certain rate. And then as soon as you become a high volume customer, your rates are different. You're going to get these preferred rates, and all the rules change for you. And where that happens is this shift takes place. And so we get piecewise functions. So from the period of 8 p.m. to 1 a.m., we have these questions. What is the rate of change? How fast is the snow coming down? What's the starting value of the output variable y? And then complete the modeling equation, y equals. So work on this individually, and then I'm going to put you into your groups again. But get going individually first. Okay, I'm going to put you into your groups. All right, so let me ask group 3, what's the rate of change?
Oh, my bad. I was talking with the muted mic.
Right.
Uh,
Easy to do.
so yeah. So would the rate of change be just 2 per hour until it hits obviously the constant at 1 a.m.
Ah, very good. So it's 2, and what's the units of this rate of change?
2 inches.
And now, all right, um, hang on a second. This thing starts to act up after a while sometimes in OneNote. All right, 2 inches. There's another part of it. Goes on the bottom.
2 inches per hour.
Very good. 2 inches per hour. Now, whenever we do the rate of change, it's always, we use this delta for change in the output over the change in the input. And David, we have a name for this. Do you know the name of this?
Delta. Would it be? I don't know. I could kind of think of it. It's delta something, right?
Uh, it's, we tend to use the letter M, and M stands for what word?
Slope.
Slope.
Oh, okay.
That's right. All right, so rate of change is the same as the slope, and hopefully that's ringing some bells and you're remembering a little bit of that from previous math courses. Okay. And then, all right, part B, what do you have for that?
Would the starting variable be the starting value? My bad. Be 20 since there's already 20 inches of snow.
Very good. So it's the output that when you started, the starting value of y, and y is inches. Okay? And then, what about the modeling equation?
I we honestly didn't like have any idea how to show. I guess the once it gets to constant, but would it be I don't know, like 2x plus 20?
All right, now you said, very interesting, you said you have no idea how to do it once it gets to a constant. It's a very good observation. And this is asking just for the period from 8 p.m. to 1 a.m. So it's just up to where it becomes a constant. And so we're not asking for anything after that at this point. But it is 2x plus 20. You are right. And the format that we're using here, let me point this out. This is the same as, that's the slope. There's a fancy name for this one. It's called the y-intercept. The starting value, what we mean by starting value is when x is 0. When x is 0, then you don't go over left or right, you just go straight up on your graph, and your y-intercept is 20. And so we have the slope and the y-intercept. The letter we tend to use for y-intercept is b. And this is y equals mx plus b. And it makes sense in this case. The 20 that we started with is a one-time deal. Started with 20 inches. The 2 is the variable kind of thing. It's how these two relate to each other. Every time the x goes up by 1, the y goes up by 2. So increasing the x by 1 causes the y to go up by 2 only if you multiply the x by 2. And so that's the essence of the relationship between x and y is in that m. Every time the x goes up by 1, the y goes up by 2. The b isn't so much about the relationship between x and y, it's just like, what does y start out as? Y started out with 20, and then The m is the essence of the relationship between x and y. X goes up by 1, y goes up by 2. Okay. So now then we go to, for the period 1 a.m. to 7 a.m. In this part, I'm going to do, what is the rate of change? Well, from 1 to 7, it doesn't change at all. It stays at 30. So we say that this is 0. And the units are the units of the output, inches per hour, over the units of the input. What's the value of the output variable y? It's always the same, it's 30 inches. Complete the modeling equation. It's going to be mx plus b again. It's going to be 0x plus 30, or it's just y equals 30. For what domain is this equation relevant? Only when x is what? When x is between 5 and 11, then that equation. X is between 5 and 11. Alright, so now your instructor will show you the piecewise function that represents the snow depth for the entire period. Now that's just what David was saying. Saying, I can come up with the equation for this first part, and this equation doesn't look that complicated, but what about the equation that does both together? Well, this is going to require something new. And the format is this. F of x, or y, equals, and we give the two situations. The first situation is 2x plus 20. 2x plus 20, but we only use that, comma, when x is when? X is between 0 and 5. Now I could put less than or equal to here. But if I put less than or equal to here, then I'd have to take out the equal sign over here. It doesn't really matter which one has the equal sign, but we can't let both of them have the equal sign, because we have to have specific instructions. Use one equation for one set of the inputs, and use the other equation for the other, and have no overlap in these numbers. The other one is 0x plus 30, which I'll just reduce to 30, and we use that when x is between 5 and 11. And again, if I put the equal sign not here but up here, that would have been okay. Either way, why is it okay either way? Because if you put a 5 in up here, you're still going to get the output of 30. Or if you put the 5 in as your input down here, you get the same output either way. All right. Any questions on this strange new thing called a piecewise function? We've set the pieces up. Now, there's an implied if right over here. And sometimes they actually write the if. And sometimes they leave it off. And when you read one of these things out loud, it makes more sense if you start with the if part. Instead of saying y equals this, if that, you start if the input is between 0 and 5, then the output is this. And then if the input is between 5 and 11, then the output is this. And that's generally how we read them out loud. All right. Now, we've run out of time, so let me just show you this quick part at the end that will help you with some of the homework. And if you have a situation like this, out of context, then to fill in the table, actually, let's just, the next time that we meet, I'll pick up here and we'll finish this. So, when you're doing the spot check, when you get to the piecewise function part, you don't have to do that part. So the 3.2, let me look at the assignment. Do up through number 30 for the spot check. Okay. And I'll edit the spot check thing in Canvas. So up to number 30, and we will stop here. And David and Jason, today's your first day, so hang on for just a minute, and we'll stop class here for everybody else, but I just want to check in with you two, make sure you understand how things work in this class since you missed the first day. So the homework is 3.2, have at least 75% for the spot check up to number 30. For tomorrow's spot check. And any questions about anything else? All right. Oh, the problem that you've got to work on today with your group is number 42. So let me send you to your groups for a quick minute so you can make a plan for how you're going to check number 42, and then I'll talk briefly with Jason and David. So let me show you the groups.